have learned, alright, basically how a vector is being represented. Okay, then after that, how do we write a column vector, and how we also understood something about parallel vectors. Okay, so for parallel vectors itself, we just have to observe that the lines are actually parallel to each other based on how we see our parallel lines. Okay, and then after we are able to see that they are parallel if they actually go in the same direction or opposite direction. Okay, so we already addressed also the opposite and different. Opposite direction and different direction, they carry different meanings. Right, so don't use them in a similar manner. Okay, so then after yesterday, we have also covered how to actually go about drawing our vectors. Okay, we have learned how to do the triangle law as well as also the parallelogram law. Okay, so let's continue with this. Okay, for addition of vectors. 那小虎一会儿一起抄我们Okay, so let's get example 6. Sorry, let's do this. Okay, so for the two drawings, if we were to take that A is having the vector 2, 3 and B is having this vector, okay, if we were to add these two vectors up, okay, we see that the resultant vector itself, alright, has a column vector of 1, 2, 3, 4, 5, 6, 6 by 2. Okay, so therefore it is 6 to the right, positive 6, and then after that 2 downwards, so therefore negative 2. Okay, so that is what we can observe from the resultant vector itself. Okay, so observing the original given vector A and B, right, we see that actually the x components, they add up to give you the x component of the resultant. Likewise, the y components of the two vectors, they add up to give you the resultant, the y component of the resultant vector. Okay, so therefore, we can conclude that if I were to add up two vectors, okay, it will give you the addition for the x and addition of the y. Right? Then after yesterday, we also learned about notations. Okay, if we were to look at such notations, the thing in the center must actually be the same, so that we can take the starting point to be P and then the ending point to be R for this particular case. So in part 1, if I want to simplify the vector PQ plus QR, that will give you the resultant PR. Now what if, okay, I have SR plus PS. Okay, looking at the diagram itself, SR refers to this one, and then PS refers to this. Okay, if I were to go ahead and draw a parallelogram out of this, let me just do a quick sketch now. Okay, so SR is actually this one, and then PS is this one over here. Okay, so we say that SR being like that and PS over like that, okay, either you can draw a parallelogram or you can draw a triangle. Okay, you can find that the resultant vector is going to give you this. Okay, but then what we can also observe is that if there is no diagram given to you, then how? Okay, we can actually notice that this allows us to swap around. Okay, we see that there is a common point S. Okay, so I can actually swap this around to write it as PS plus SR. Okay, so that it actually gives me the resultant PR. So for addition of vectors, okay, it is actually commutative, right? Meaning to say that you can actually, it's just like your usual 2 plus 3 and 3 plus 2. Okay, so if there is no diagram given to you, you could actually present your answer in this manner. Let me present it properly. plus SQ. So following by the rule that we have, okay, we can see that these first two, okay, they can add up together to give you PS. So then after that plus SQ, and therefore that will give you PQ in the end. So if you want to look at the diagram and make use of it, PR actually refers to this vector here, and then RS refers to this one, SQ refers to this. Yes? Why? Oh, okay, sorry. Let me draw pictures up. Okay, PR refers to this one, then after RS, and then after SQ is over here. So if this were to be the starting point, okay, we see that at the end of this addition, we end up over here. So therefore, it is actually the same as P2. Right? So actually, we notice that using this diagram, we can get answer PQ. But if no diagram given, we can also understand that these two add up to give us PS, and then after that, PS plus SQ, that will give us PQ. Okay? Any questions? Move on. Okay, let's look at the magnitude of a resultant vector. If we are given that A and B are actually this, we can compute what is the magnitude. That will give us square root 13, and then for the magnitude of B itself, that will give us square root 41. Okay. So earlier, we would have found that the resultant vector A plus B, that would give us 6 and negative 2. So therefore, finding the magnitude of the resultant vector A plus B, upon computation, that will give us square root 40. So clearly in this case, okay, if I were to add up the magnitudes separately of A and B, it does not give us the magnitude of A plus B. This is a consistent understanding of our modulus that we have learned in AMAX. Okay. Any questions so far? Next, let's look at zero vector. Consider a person walking in a straight line from the front of the classroom, okay, to the back of the classroom, and then the person from the back of the classroom walks back to the front. Okay, so to represent this entire journey, if from the front to the back, we represent it with the vector PR, and from the back to the front to be the reverse, which is RP. Okay, we will see that PR plus RP will of course be 0. It's because the displacement in reality, as it walks in this manner, it goes back to the origin, so the displacement will have to be 0. Okay, so therefore, okay, likewise, if it works from the back to the front and then from the front to the back again, okay, taking the origin from the back of the classroom, okay, this will also give us 0. Okay, so 0 is a 0 vector, okay, it is not a scalar. So when you add up two vectors like that, okay, that actually RP is the negative of PR. Okay, so in other words, we can write PR plus RP as a consideration of PR minus RP itself, minus PR. Okay, it doesn't give us just any 0. Please be consistent in writing, it must be 0 vector. Okay, it's very common that people just write 0, okay, without showing that it is a vector. Okay, so make sure that your notation wise, when you add two vectors and they end up becoming 0, it must become a vector still. Okay, what a 0 vector is, it is just simply as good as writing 0, 0 in the column vector wise. Alright? If you just write an empty 0 without the tilde sign at the bottom, it is just going to be a scalar number. Scalar number means that any integer that you have on your calculator, okay, without direction. Okay, two vectors cannot add up to become a scalar. Alright, so therefore, looking at example 7, to simplify this, okay, adding up these two vectors, the x and x add together, y and y add together, we will notice that it will give us a 0 vector. Okay, in this case, you can write out as 0, 0, or you can actually write it as a 0 vector. Yeah. Both will be understood. But you cannot write down just a plain 0 itself. This vector equation given to you, okay, what is the y component that should be here? Such that you give to 0, negative 7, right? And this will be 6. Okay. Now let's look at vector subtraction. If you're given R to be this vector here and S to be this vector, okay, we find that R will have a column vector of what? What's the column vector for R? Sorry? 3, 5, right? And then S will actually be 6, 2, right? Now what if I want to draw the vector R minus S? Okay, minus will mean that it is the opposite direction. So let's first start with drawing the vector R. So 3, 5, 1, 2, 3. Okay, so this is the vector R that I have. On your preference, whether you like the triangle or the parallelogram, which one do you prefer? Triangle. Okay, so if we start from here and at R here, okay, then after that we have to continue from here to have our vector S. Okay, vector S has a column vector 6, 2, but we are looking at minus S. Okay, so it will have to be the opposite direction. Okay, so that means negative 6, negative 2. So therefore, this will be the vector negative S. Hence, we will be able to see that the resultant vector have to be this. So starting from here and here, right? So your arrow must be pointing in this direction. And this is the resultant R minus S. Express each of the vectors R, S and R minus S as a column vector. Okay, so we have already gotten R and S. So let's write it down formally. Okay, so we find that R minus S, looking at the diagram itself, okay, the vector would be negative 3. Okay, and then after that, upwards by 3, so negative 3, 3. So then after that, finding the magnitude of R, S and R minus S. plus S. Yeah, you can have R plus S, but that's not the concern that you have. Sorry. 997 gram R plus S. But the question was R minus S. Try to conserve it or conceptualize it. Okay, so looking at the magnitudes that we have for Rs and R minus S, okay, we also observe that surely the subtraction, the magnitude of the resultant vector is not equivalent, okay, to just taking the magnitude of the individual vectors, okay, then after taking that difference. So this is not true. Okay, so likewise it is consistent with our understanding of modulus. At this. Yeah, I understand that this topic is very dry. It's something that you all have already grasped and it's rather simple to grasp. Okay, but we really have to lay down these basics so that we can do our very last part, 5.7, which is the more important thing, okay, with easier as in with vector skills. Okay. Okay, so example 9, we want to find out what is the resultant vector represented by the double arrow in each of the diagrams below. Okay, so resultant vector meaning to say that I want to find out what is the combination of A and B that allows me to have this resultant vector. Okay, so looking at A being like that and B being like that, okay, what do you think is the combination of A and B that would allow us to have this vector here? Okay, so if I were to look at the start point, which is here, and end point to be here, okay, I can also see it as a parallelogram based on my parallelogram laws. So B will actually be this vector here, and then after that, I need to go downwards in order to get back to the end point, right? Okay, sorry, it's not a very good parallelogram. Then after going downwards will actually be this. Alright? So this downward vector, what would it actually represent? It's supposed to be a parallelogram. Let me go back one. What is that downward vector supposed to represent? Negative A, right? Because upwards is actually A, so downwards must be negative A. A is supposed to be a parallelogram. So therefore the resultant vector will actually be B minus A. Okay, let me write it. Okay, so the resultant of part A is B minus A. Does anyone not get what I'm trying to say? Okay, could you do part B, C, D, and E yourself? Find out what is the so-called expression, okay, of the respective given vectors, so as to be able to allow you to find out what is the resultant vector.
A minus B.
A minus B. Anything else? Okay, we can also write it as negative B plus A. That is fine as well. Okay, then what about part C?
M minus N.
M minus N, okay. What about part D?
W plus B.
Okay, W plus B. And then for part E, what do you get? Negative B minus W, okay. So earlier on someone asked me, can this negative so-called be factorized out? Okay, it can, because if I were to so-called do the factorization, I'm expecting to get it like that. Okay, if you understand what does V plus W actually means, V plus W, okay, that means going into this direction, then after following by this, we will get the resultant vector of starting from here up to here. So it is actually the opposite direction of this given vector here. Okay, For opposite vectors, we understand that they are negative of each other. Okay, so therefore they are actually meaning the same thing. So you must be able to recognize that they mean the same. Okay, but then of course in this case, either one of it as the answer is fine. Okay, let's look at example 10. We want to express these 5 vectors over here in terms of P and Q, Pn slash or Q. Okay, so PR itself, what would the vector actually be? Q, right? What about RQ? RQ is equivalent to what? It will be negative P. What about OR? OR is this one here. What will OR be? Q plus P. Okay? Then after, what about PQ? Q minus P. And then finally QP will be, sorry, P minus Q because it's a negative of Q minus P. So you can write it as P minus Q. Or otherwise, looking at the diagram, you'll also be able to get this. Right? Yep.
For the one on top, right, the example 9, right? You
Uh-huh.
cannot just use, for example, part A. You cannot just A plus B because there's no start point and end point.
A plus B.
Like, why do you need to draw the other side of the parallelogram?
Oh no, I'm only trying to show you. I mean, you can actually don't need. Depends on how you want to see.
Because you cannot get the resultant form.
Resultant, so that negative A plus B, no? So can so I don't need to draw this.
Huh?
Look at part A, right?
Oh.
From start to end, negative A plus B. Or else, if you want to think about it like that, it really depends on the perspective. Okay, because for example, right, for your QP over here, sorry, QP over here, right, some of you might be looking at the top half to decipher that it is negative Q plus P, but some of you might be looking at this part here, thinking at P, then after minus Q. So it really depends on how you want to see your triangle or your parallelogram. Yes.
On the line because right below you
Right below the capital letter.
actually right below.
This is not a tutor, it's the arrow sign.
No like that.
Or below. Are you that part? That doesn't matter. It doesn't matter. But usually people don't write like that. It doesn't matter. It's not. It's. Yeah. Sorry, I'm first time getting this kind of question. Okay. So let's look at the next section. Okay, or rather the next half that I gave you today. If you didn't staple it together. Okay, let's look at simplifying all these vectors over here. We definitely know how to do part 1 already, or rather part A. Whereby AB plus BC is actually equals to what? AC, right? What about AB minus AC? How do we actually do that? Okay. We know that AB minus AC actually refers to a class CA. Do we agree? Okay. Negative AC is the as plus CA. So in other words, okay, I can actually then flip it around by writing CA plus AB. Then I will be able to get that the answer will be CB. Okay? So when it comes to vector subtraction, there is no straightforward way of getting it. Okay? You need to be able to see what is the opposite to change it into plus. Then after you'll be able to decipher, okay, where is the start point, where is the end point, and what is the answer. Alright?
So minus just split the thing.
Yes, so minus just split. Huh? Why? Okay, part C, we have AB minus BC. Okay, so in this case, we want to change it into an addition in order to simplify this. So therefore, there will be AB plus CB. But then, does this give us anything? Okay, it doesn't give us anything, so this cannot be simplified. Alright? Okay, so in other words, also this cannot be simplified. That means there's no resultant vector out of this also. Okay. Because they are two separate vectors. Then after next, you look at PQ minus PR. So changing it into addition, so that will be PQ plus RP. Here we can, in this case, swap them around. And that will give us the resultant vector RQ. Okay, can you do for part E and part F? And see what is the simplified vector. answer PR and SQ?
Yeah.
Alright? Okay, I want you to very quickly also do question 12. I believe you know how to do this. It is similar to how we do our next